You know, humanity has always had this obsession with building higher. We just can't help ourselves. We want to pierce the clouds with these incredible towers of steel and glass. But the taller we build, the crazier the engineering challenges get. To reach these incredible heights, engineers have to outsmart some of the most powerful forces on Earth. And that's really the first big question, isn't it? How do these massive structures stay standing against something as powerful as the wind? I mean, when you're talking about a building 100 stories tall, the wind isn't just a gentle breeze. It's a relentless, powerful force that's constantly trying to knock the whole thing down. So what happens is, as wind whips around a big, flat building, it creates these little whirlwinds on the other side. They're called vortices, and they detach one after the other, from one side then the other, creating this rhythmic push-pull on the building. Now, the real danger is when that rhythm perfectly matches the building's own natural sway. It's just like pushing someone on a swing at the exact right moment. Even a tiny sway can get amplified into a huge, catastrophic wobble.
Okay, so to stop a skyscraper from literally shaking itself apart, engineers have come up with some absolutely brilliant ways to tame this powerful force, and they basically boil down to two different approaches.
And what's so cool is how different these two philosophies are. You've got the brute force method, like in Taipei 101. Inside, there's a gigantic 730-ton steel ball that's basically a pendulum. When the wind pushes the building one way, this massive ball swings the other way, canceling out the motion. It's just raw power. But then you have the elegant solution of the Burj Khalifa. Its incredible spiraling shape is designed to confuse the wind, so those powerful rhythmic vortices never get a chance to form in the first place. It outsmarts the problem before it even starts.
So you'd think, okay, problem solved, right? We've got these incredible ways to deal with the wind. But what if the biggest danger isn't coming from the outside at all? What if there's a hidden enemy lurking deep within the structure itself?
And that is the absolute key here. The moment a building starts to sway, even just a tiny bit, its own colossal weight suddenly starts to play a brand new and very dangerous role. The very force that's meant to hold it down can actually start helping to push it over.
This brings us to a really fascinating concept in structural engineering. It's what they call a second-order effect. It's a kind of hidden physics that only really matters when you're building on these massive scales, and it's called the P-delta effect.
So, what on earth is it? Well, it's actually pretty simple when you break it down. P stands for the vertical load. That's just the building's enormous weight pushing straight down. And delta is the symbol engineers use for displacement, or how much the building is swaying to the side. The P-delta effect is what happens when that weight and that sway combine to magnify the stress on the entire structure.
Let's make it super simple. Imagine one vertical column. To start, you've got the building's weight, P, pushing down, and then you've got a side force, F, let's say from the wind, pushing it sideways. Well, as soon as that side force hits, the column starts to bend. That little bit of sway is what we call delta.
And here's the kicker. The second that building sways, its massive weight, P, isn't pushing straight down through the center of its base anymore. It's now off-center by that distance, delta, and that creates a new turning force on the building, which is equal to P times delta. This new force gets added on top of the original wind force, which makes the building bend even more. It's a dangerous feedback loop. A little sway creates more force, which then creates even more sway.
Okay, so this isn't just some abstract theory. It has very real consequences. The big question is, when does this P-delta effect go from being a tiny detail to a critical must-solve safety problem? Well, a fascinating engineering study gives us a surprisingly clear answer.
So what they did was, they created computer models of 3 concrete buildings, one at 20 stories, one at 25, and one at 30. They all had the exact same floor plan to keep things consistent. Then, they simulated an earthquake hitting them. And here's the clever part. They ran the simulation twice for each building, once using the standard calculations, and then a second time adding in the P-delta effect. And this right here is the actual 3D model they used in the software for their analysis. So this isn't just an idea on a whiteboard. Engineers build these incredibly complex digital twins to see exactly how these forces are going to behave in the real world. So, what did they find out? The results are just crystal clear. For the 20-story building, adding the P-delta effect increased the maximum sway by about 9.8%, so just under 10%. But look what happens next. At 25 stories, it jumps up to almost 14%, and for the 30-story building, it's over 18%. The effect isn't just getting bigger, it's getting worse, faster the taller you go.
And it turns out there's a magic number in engineering that this data blows right past.
And that number is 10%. It's the official line in the sand.
And this isn't just some friendly advice from a textbook. It is written into the rule book. The National Building Code literally says that if these second-order effects, like P delta, increase the internal forces by more than 10%, you have to account for them in your design. It's not optional. And what that study showed is that for buildings, that line gets crossed right around the 25-story mark.
So what does all this mean for the future of our cities, for our skylines? Well, it means the rulebook for building really, really tall has fundamentally changed.
So, here's the bottom line. For any modern high-rise, you just can't ignore this hidden force anymore. The old way of doing things, which basically assumes the building stays perfectly rigid, it just doesn't cut it. Factoring in the building's own weight turning against itself is now an absolutely fundamental part of the design process.
But this isn't a bad thing. It's not a limitation. It's actually what unlocks the next level. Understanding and mastering these complex, hidden physics is precisely what gives us the confidence to build even higher. It's what makes a crazy ambitious structure like the Jeddah Tower, the first building ever designed to be over 1 kilometer tall, even remotely possible.
It really makes you wonder, doesn't it? Our whole quest to build to the sky is this constant dance with forces we can see and these other, hidden forces we have to uncover. As we keep pushing the limits of what's possible, the real challenge isn't just about stacking floors higher, it's about discovering the next hidden force that's waiting for us up there.